Let's take a look at the solution to exercise 1. The exercise was to return all the data from the actor table. So the way you write a query, you start with the select statement followed by the asterisk. Asterisk means return all the records stored in each of the columns or fields in the table. From is where you specify the table you are getting the data from. So I'm getting the data from the actor table. When you execute this query by pressing on this button here, it should return 200 rows. One thing I like to do is format my query so that it looks nice and tidy in the editor. So I'm going to select edit and then go format and select beautify query. And you can see here it has spaced out the query. It makes it more legible to read and also to understand. Let's take a look at the solution to exercise 2. The exercise is to return specific fields from a table. So we want to return the first name and also the last names from the staff table. One thing I like to do is take a look at the table structure first. So you run this command and that will return the table structure. So we can see the table structure. The reason I like to see the table structure is that I want to make sure I have the exact column field names as specified in the table before I write my query. So this is my query here. I'm selecting the first underscore name, comma, the last underscore name. You can see in the description of the table, the first name is spelled first underscore name, last name is last underscore name. So I've specified the way it was specified in the table in my query. Line number 3 is where I specify what table the data is coming from. Line number 4 is the name of the table, which is called staff. So when I execute this query, I should only return 2 columns, the first underscore name and the last underscore name. So I'm going to click to run it. The query has returned 2 rows. You can see the rows here for Mike and for John. Let's take a look at the solution to exercise 3. Exercise 3 requires returning specific customer details. We only want to return the records that matches customer details based in USA and Venezuela. So we want the name, the city, and the phone number of customers based in USA and Venezuela. We need to make sure that we are returning the data from the correct table. So if we look at the tables in the Sakila database, we have a table called customer. So let's take a look at the structure of that table by running this command here. So you can see the structure. So these are the fields on the table, but this particular table has not got a name field. It also does not have a city field, also does not have a phone field. So if you look on that field here, there's no name, no city, and no phone. So this is not the correct table we want to return the data from. The Sakila database also has virtual table. So these are the main tables, but if we look here under views, we have some virtual tables. So I'm going to expand that, and you can see under the views we have some tables. All these tables are known as views. A view basically is a database object that has no values. The content on the tables in a view are based on a base table, so they are getting their content from another table. So the actual data that you find in a view are coming from another table, which is known as a base table. So you can have a view created by joining one or more tables together. So let's take a look at this view table here, which is called customer_list. So I'm going to run this command to see the structure. And if we take a look, we have a name field, we have a phone, and we have a city. So this is the table we want to get the data from. This is the query that I'm going to use to retrieve the data I want. So line number 1, we have the select. Line number 2 is where I specify the name of the fields that I want to return data from, which is the name, the city, and the phone. Line number 3 is the from, where I specify the table that I want to get the data from. The table I'm getting the data from is on line number 4. The table is called customer_list. On line number 5, we have the where clause. The where clause is a powerful tool that allows you to filter which rows or records are returned from a select statement based on the conditions you have specified. So the conditions I've specified are on line number 6. So I only want to return records from this table where the country is United States or the country is Venezuela. When I execute this query, it will only return rows where the value for the country is either United States or Venezuela. So let me execute. I hit this button here and you can see it has returned 43 rows that matches the condition I have specified in the where clause. When you're running a query, if the table has a lot of records, you can limit the amount of rows that it returns. So here we have the drop down. So for example, if I only wanted to return the first 10 records, I can click 10 rows. And if I run this query again, it will only return 10 rows. You can see here, it says 10 rows returned. Let's take a look at the solution to exercise 4. The task for the exercise is to return all the cities belonging to Brazil that is stored in the database. So we have a city table. We also have a country table. So I'm going to take a look at the structure of both tables. So I take a look at the structure of the city table first. So I select that and run this query. And this is the structure. So we have a city_ID. We have the city and we have the country_ID. And then we have last_update. So let's check the structure of the country table. So I'll select that and run it. So the country table has a country_ID, has the country, and also has this last_update. So the country_ID is a common field in both the country table and the city table. So both tables are related via the country_ID. So what I need to do now, I need to find out what the country ID of Brazil is. To do that, I'm going to run this query, select star from country. This query has returned 109 rows. So I'm going to scroll through and find Brazil. So we can see here, we have Brazil here has got a country ID of 15. So now I have the country ID, which is 15. I'm going to use that to query the city table. This is my query. So on line number 1, we're using the select statement. and we are selecting the city column from the city table, where the country underscore ID is 15. Because what we're trying to achieve, we're trying to return all the cities in the country Brazil. So we've been able to determine that Brazil has a country ID of 15. So let me run this query. The query has returned 28 rows. So we have 28 cities in Brazil as stored in the database table. Let's take a look at the solution to exercise 5. The task for exercise 5 is to return all languages except Italian. So we have a language table. So this is a language table here. I've already executed this command to display the structure of the language table. So you can see the language table contains these fields: language underscore ID, the name, the last underscore update. I'm going to query the table to return all the data so I can see what language underscore ID is for Italian. So I'll select this query and then run it, and we can see that Italian has an ID, a language ID of 2. So I need that to construct my query. Here is the query I have constructed. On line number 2, we have the select statement, and on line number 3, we have the field from the table that I want to return data from. So we have the language underscore ID, comma, and then we have the name. When you're listing multiple columns, you have to separate them by a comma. Line 4 is the from field where we specify the table. Line 5 is the name of the table, which is called language. Line 6, we have the where clause. This is where we specify the condition that would determine what rows of data is returned by the query. On line number 7, I have used the not equals to operator. The condition in the where clause indicates that it will exclude any record that has an ID of 2. As we can see here, the language ID of 2 belongs to Italian. So let me run this query. The query has returned 5 rows. So if we look at the query result here, we can see that Italian has been excluded from the result. Let's take a look at the solution to exercise 6. The task for exercise 6 is to return the first names of all the actors beginning with A. So here is the structure of the table. The table has an actor underscore ID, a first underscore name, last underscore name, and the last underscore update. This is my query. So when I execute this query, I expect it to return only the first names of actors beginning with the letter A. On line number 2, we have the select keyword. On line 3, we have the first underscore name column. On line number 4, we have the from keyword, where we specify the name of the table, which is displayed on line number 5. So the table I am retrieving the data from is called the actor table. Line number 6, we have the where clause. On line number 7 is where I'm specifying the condition that the where clause is going to use to filter the records that are returned by the query. So I am filtering by the first underscore name. I've used an operator here. The operator I'm using is less than. So I'm saying it will only return the first names where the letter is less than a B. So let me execute the query. The query has returned 13 rows. And if we take a look inside the result area here, we can see that we only have first name beginning with A, as I have specified in the where clause condition of the query. Let's take a look at the solution to exercise 7. Exercise 7 requires you to find the films that has titles containing the word family. So what we need to do, we need to find a pattern in the data that's going to be returned by the query. We can do this using the like operator in a where clause. The like operator is used in a where clause to search for a specified pattern in a column, which we want to do. We are searching for a pattern. That means we're searching for film titles that contain the word family. Usually a like operator is used in conjunction with two wildcards. The first wildcard is called the percent sign, and that represents a 0, a 1, or multiple characters. The second wildcard is the underscore sign, and this represents only one single character or one number. This is the structure of the table. The table has a title column, which is the column that we are going to focus on. So we're going to be looking for a pattern in that column. So we want to find all the titles that contain the word family. This is the query I have written. So on line number 1, we have the select keyword. On line number 2 is the column I want to search for the data, which is the title column. Line number 3 is the from keyword, where we specify the table that the data is coming from. On line number 4 is the name of the table. Line number 5 is the where clause. The where clause is where we specify the condition that will determine the data that is returned by the query. On line number 6 is where we specify the condition, and the condition is we want to search for a pattern in the column called title. So we are using the like operator. The like operator is basically used to search for a specified pattern in the column, and the pattern that we are searching for is family. So we want to search for any film that has a title containing the word family. So let's go ahead and run this query. So you can see that it has returned a record of 3 rows. So you can see these are the titles. The family is actually at the end of the word. If the word family was at the beginning, the search would have still picked it up and returned it because of the way the wildcard was placed in the query. That means anywhere it finds the word family, regardless of where it is placed in the title, it will return that record. Let's take a look at the solution to exercise 8. Exercise 8 has 3 separate tasks. The first task is to find the titles of sci-fi movies that are rated PG. The second part is to find all the movies in the children or family categories. The third part is to list the sci-fi or family movies that are rated PG. So we have 3 separate queries to construct. The table we are going to be getting the data from is the film_list table. So this is the structure of the table. This table has all the fields we want. So we have the title field, we have the category field, we also have the rating field. This is the query for the first part of the exercise. I want to display all the films that have the category of sci-fi and also has a rating of PG. So I'll quickly run through the query. Line number 1 is the select keyword. On line number 2 is where I specify the column that I want to be displayed in the result. So the column that the result of the query will display is title. Line number 3 is the from field, which is where you specify what table that the data is going to come from. Line number 4 is the table. The table is called film_list. Line number 5 is the where clause. Now the where clause is very important. This is where you apply the condition or the filter that will be used so that the query only returns the records or rows that matches the criteria I have set in the where clause. On line number 6, under the where clause, I've specified that I am looking for any film in the category column that has the word sci-fi. On line number 7, I have the AND operator. The AND operator basically is used to restrict the result so that the result that is returned are only those that matches the conditions that have been set in the where clause. I'm going to execute the query. So the query has returned 12 rows that matches the conditions I have set. The titles listed here all belong to the sci-fi category and also have a rating of PG. The second task for exercise 8 is to list all the movies in the children or family categories. This query here is similar to the first query. The difference here is that on line number 7, I've used the OR operator. When you're using the OR operator in the where clause, it will restrict the rows that are returned that matches either of the condition. So it will return anything in the category that matches children or anything in the category that matches family. So let me run this query. So the query has returned 129 rows. So this title here are for any category that matches the word children and also family. The third part of exercise 8 is to find out all the films in the sci-fi or family categories that are rated PG. So this is the query I have used. So in this query here, I'm using a combination of the AND, the like, and the OR operator. Notice that I have used parentheses on line number 6 and on line number 7 here. So by using parentheses, I am making the evaluation order clearer. So anything that has a parenthesis around it will be evaluated first. So what will happen is that the movies or films from either the sci-fi or family category will be evaluated first, and then we will evaluate whether they are PG rated. So let me go ahead and execute this query. So this query has returned 30 rows. So the rows should have categories of sci-fi and family, and also should also have a PG rating. Looking at the result returned by the query, it is difficult to tell whether the category that the query has returned belongs to either sci-fi or family and also has a rating of PG. This is because we've only included the title to be displayed by the result. So if I want to see the other columns like the category and the ratings, I can come here on line number 2 and just add the category and also the rating, and that will then be displayed in the result. So I've added the columns here on line number 2. I've added category and I've added rating. If I run the query again, we should see the result. Now you can see clearly the results. Now that I've added the category and rating columns, so you can see the query is correct. Let's take a look at the solution to exercise 9. Exercise 9 has 3 components. The first one is to return a list of the first 10 customers' names in alphabetical order. The second component is to return a list of the last 5 address updates. The third component is to return a list of 10 addresses and their districts. The addresses should be in descending alphabetical order and the districts should be in ascending order. Let's start with the first component, which is to return a list of the first 10 customers' names in alphabetical order. The first thing I want to do is to find out the structure of the table. So I type in the command DESC, which is this one here, followed by the table. Because the information I want is relating to customers, so it must be in the customers table or customer list table. So I type in customer. So as I'm typing, I get some suggestion here. So this is a customer table. It tells you this is a table and this is a customer underscore list. This is a view. So let's try the customer table first and just run that query. So this is the structure. These are all the fields. So what I'm looking for here is a name field. I've got a first name, I've got a last name, but I have not got a name field. So this is not the table I want to get the data from. So I'm going to run this command on this table, customer underscore list. This table is a virtual table, which is known as a view. So I'm going to select that and run this. And if we take a look at the structure of this table, I do have a field called name. So this is the table I want to get the data from. This is the query that I'm going to use to return the data I want from the database table. Line number 1 is the select keyword. On line number 2 is where I specify the column that the data is coming from. So this data is going to come from this column called field. Line number 3 is where I specify the table the data is coming from. Line number 4 is the name of the table. On line number 5, I've got the order by keyword. The order by keyword is used to sort the result set of the data in ascending or descending order. If you're sorting by ascending, that is from A to Z. If you're sorting in a descending order, that is from Z to A. The default is to sort by ascending. And when you use the order by keyword, you have to specify what column that you are going to order. So the column I'm going to order is the name column. This is where I want the data that is returned to be sorted. And then on line number 6, we have the limit clause. The limit clause basically is used to restrict the amount of records that is returned by the query. So let's execute this query. As you can see, we have 10 rows returned as we have specified in the query here on line number 6. And if you notice here, the names of the customer are in alphabetical order. The second part of exercise 9 is to return a list of the last 5 address updates. So the table I'm going to be querying is the address table. So I'm just going to check out the structure of the table. This is what the table structure looks like. So what I'm looking for here is the last 5 address updates. So you can see we have a field here called last underscore update. This is a query that I'm going to use to get the data out of the database. So line number 1 is the select keyword. On line number 2, I've specified 2 columns that will be displayed in the result. I've got the address and also the column called last underscore update. Line number 3 is the from keyword, where you specify the table the data is coming from. Line number 4 is the name of the table, which is called address. Line number 5, I'm using the order by clause. This is what I'm using to filter or sort the data. On line number 5 is the order by clause. The order by clause is used to sort data. So I'm going to be sorting the result of the query using the last underscore update column. Line number 6, I'm using the limit clause to restrict the amount of rows or records that are returned by the query. So the query is only going to return 5 records. So I'm going to execute this query. As you can see, it has returned only 5 records, which is what I specified in the query. If you take a look at the result, you can see under the last underscore update, which is a column that we apply the order by clause to, you can see the order in which the addresses were updated in terms of the dates. So this is the earliest date and this is the last updated date for the addresses. The last part of exercise 9 is to return a list of 10 addresses and their districts. The addresses should be in descending alphabetical order and the districts should be in ascending order. The table I'm getting the data from is the address table. This is the structure of the table. So the columns I'm interested in getting the data from is the address column and also the district column. This is the query I've written to get the data out of the database table. On line number 1 is the select keyword. Line number 2 is where I specify the columns that I want to get the data from. So it's the address and the district column. Line number 3 is the from keyword, where I specify the table the data is coming from. Line number 4 is the name of the table, which is the address table. Line number 5, I'm using the order by keyword. This is used to sort the data that is returned by the query. When you're using the order by keyword, you have to specify what column or columns that you want to sort the data from. I want the data from the district column to be sorted in ascending order. That is from A to Z. So that's why I've used ASC, which is short form for ascending. While I want the data that is going to be returned by the address column, I want that to be sorted in a descending order. Descending meaning from Z to A. So that's why I've got DESC. Line number 6, I am restricting the amount of records or rows that this query is going to return. So I'm limiting the rows to 10. So let's execute this query. As you can see, we have 10 rows returned, and the data has been sorted by ascending order for the district and descending order for the addresses. Let's take a look at the solution to exercise 10. The task for exercise 10 is to return 10 records showing the names and customer ID of customers, but skip the first 5 records. First thing I want to do is see the structure of the table. So I'm going to check this table called customer. So I'm going to select it and then run the query. So this is the structure of this table. So what I'm looking for is the names of the customer and also the customer ID. So here we have customer ID underscore ID. We have the first underscore names and the last underscore names. Now that is not what I want. I want the column that just says name. So I'm going to go over to this structure here. This is actually a view. A view is a virtual table, and you can query a view just like a normal table. So I'm going to execute this query to see the structure. This table has an ID field. It also has a name field. So these are the 2 fields I'm looking for to build my query. This is the query I have built to get the data out of the table. So I'm going to quickly run through the query here. On line number 1, we have the select keyword. Line number 2 is where I specify the columns or the fields that I want to be displayed from the query result. So I want the ID field and the name field to be displayed in the result. On line number 3, I've got the from keyword where I specify the table the data is coming from. Line 4 is the name of the table. On line number 5, I have the order by clause. The order by clause can be used to sort data that the query returns. So I'm sorting the data by the ID column. On line number 6, I have the limit clause. So what this is doing here, I'm restricting the amount of records that are going to be returned by the query. The limit clause can have 2 arguments. In this query, the first argument here basically specifies the maximum number of rows I want the query to return. The second argument specifies the first row to return. The second argument is referred to as the offset. So basically what I'm saying is that I want 10 records to be returned from this table. However, I want to skip the first 5 records. So let me run this query. As you can see from the result of the query has returned 10 rows as specified in the limit clause. It also has returned from record number 6 all the way to 15. That's because of the offset. When you use an offset, that means you can return a specified section of the data. So what I'm saying here is that I want to skip the first 5 records, only return from record number 6, which is what the result has indicated. Let's take a look at the solution to exercise 11. The task for exercise 11 is to return the following countries stored in the database, and the countries are Egypt, France, Hong Kong, and the United Kingdom. We also want to return the corresponding cities for those countries, and then we want to sort the result that is returned by the query. The first thing I want to do is to have a look at the structure of the table. So there are 2 tables I want to look at. The city table, so I'm going to select this command here and run it. This is the structure of the city table. So it has the city underscore ID. It has the city column, which is one of the columns I'm interested in. It has the country underscore ID, and it has the last underscore update, but it doesn't have the country name. Let's take a look at the structure of the second table here, which is the country. So I run that, and we can see that the country table has a country underscore ID, and then it has a country column and also a last underscore update. So both tables have the columns I want. So what I need to do here is to perform a join operation so that I can join the data I want from both tables. The type of table join we are going to perform with our query is called an inner join. With an inner join, it selects the records that have matching values in both tables. To perform a table join between tables, there must be a relationship between the tables. So if we take a look at the tables I'm trying to perform the join on, which is the country table here and the city table. So you can see the relationship they have is via the country underscore ID. So we have a country underscore ID here for the city table. We also have a country underscore ID in the country table. So that is where the join operation is going to take place. I've run a select statement on the country table so that I can identify which country belongs to the country underscore ID. So I'm going to be using the country IDs in my query. So in order to get the country ID, I have to run this query on the country table and then match the country underscore ID to the country. This is the query I have written to get the data out of the database. So we have the select keyword on line number 1. Line number 2 is where I specify the columns that are going to be returned by the query. So I've specified the city column and also the country column. These 2 columns belong to 2 different tables, the city table and the country table. On line number 3 is the from keyword. On line number 4 is where I specify the tables where the data is coming from. So this is where we're going to perform the join. So line number 4 is the city table. So I specify that first. So that is the table that I'm going to perform the join on. Line number 5 is the inner join. This is the command that is going to perform the join. So what an inner join does, it selects the records that have matching values in both tables. So on line number 6, we have the second table that is going to participate in the join, and that table is called the country. And then we have the on keyword on line number 6. The on keyword basically specifies the required columns that will be participating in the join. And the columns are from the city table. We're going to be using the country underscore ID, and we need the equals to specify the other columns from the other table. And from the country table, we're going to be using the country underscore ID. So the join is going to be performed on identical columns. So the data that matches those two columns will be returned by the query. On line number 7 is the where clause, where I specify the condition for the query. And in the where clause is where we apply a filter that will determine the records that are returned by the query. On line number 8, I'm selecting the country underscore ID from the country table. Also on line number 8, I have the in operator, and then inside the parentheses, I have different values. Now, these values here represents the country IDs that I want to return the data from. The in operator allows you to specify multiple values in a where clause. On line number 9, we have the order by clause. We're going to use the order by clause to sort the data that is returned by the query, and we're going to be sorting the data by the country followed by the city. So let me run this query. The query has returned 19 rows. So as you can see, we have the city and then we have the country. Note that the columns displayed in the results will appear in the way you've specified it in the select keyword. So you can see on line number 2, I specified the city first, followed by the country. Let's take a look at the solution to exercise 12. The task for exercise 12 is to add 3 languages to the languages table in the database, and the languages to add are Spanish, Portuguese, and Mandarin. Before you insert data into the database table, it's a good idea to take a look at the table structure. So I'm going to run this command here to see the table structure. This is the table structure. So the table has 3 fields. The language underscore ID field. This field here, you can see here we have auto underscore increment. What that means is that the database will automatically populate this field, so we don't need to provide a value for this field. And then we have the name field that we have to provide a value for. We have the last underscore update field. Again, this we can use a function to auto populate this column. To add new records into the database table, you use the insert into statement, which I have specified on line number 2. So I'm inserting into, and the name of the table I'm inserting into is the language table. Next, I have to specify the values that are going to be inserted in the table. The values you supply has to match the columns in the table. For example, on line number 2 here, null basically means empty. So when you have a null value, that means you have no value. So this null here is going into the language underscore ID. The reason I've not provided a value is because this field here is auto populated. You can see we've got auto underscore increment. So the database will automatically populate that value into this field. And then the second value, which I have supplied Spanish, will go into this name field. And then the third value, which is the last underscore update field, I've provided a function called now. The now function will return the current date and time of the database server and populate that last underscore update field. I'm inserting 3 separate records into the database table. So you can see I've separated each one with a comma. This is the first one that will be inserted, followed by this one here, and then followed by Mandarin. It's a good practice to terminate your queries with a semicolon. It indicates that that is the end of the query. Before I insert the records into the database, I want to just query the table so we can see what records we have there. I'm going to select this query here and then run it. The language table currently has 6 records. So if I insert these 3 records, it will now have 9 records. So this language underscore ID field is going to be auto populated. So that's why here we've got null, because that field is auto populated. And then this now function will auto populate the last underscore update field. So let me run this query. I'm going to select it and click to run. As you can see, it tells you here that 3 rows affected. So 3 records have been added to the database. So if I run this query again to query the table, you can see we now have 9 records in the table. So we added Spanish, we added Portuguese, we added Mandarin. You can see here for the language underscore ID, that field has been auto populated for us. And if we take a look at the time here also, that has been populated for us. And then we can see the names of the languages that were added. We've got Spanish, Portuguese, and Mandarin. Let's take a look at the solution to exercise 13. Exercise 13 has 2 tasks. The first task is that the actress Penelope Guinness has changed her last name, so we need to update this in the database. The second task is to update the language Mandarin to Mandarin Chinese. Before you update a record inside the database, it's good to take a look at the current state of the record. So I'm going to use this query here to query the actor table and look for anyone with the last name of Guinness. So if I run this here, the query has returned 3 records that matches the last name Guinness. The record I want to update is for Penelope Guinness. So she has an actor ID of 1. Notice that the first name and the last underscore name are capitalized. So when I update the record, I must make sure the last name is in capitals. This is the query that will perform the update. So to update a record, you use the update statement, which is what I specified on line number 1. So followed by the name of the table. So the table I'm updating is called the actor table, which I've specified next to the update statement on line number 1. On line number 2 is the set keyword. It is in the set that you specify the value you want to change. So on line number 3 here, I'm specifying that I want to update the last underscore name, and then you use the equals to supply the value for that update, and the value is Cruz. So I'm going to change our name from Penelope Guinness to Penelope Cruz. Notice I've got upper. This upper function here is going to convert this text called Cruz to make it capital. Because if you look here in the records here, the last name and first name are in capital. On line number 4 is the where clause. The where clause is very important in an update statement, because if you omit the where clause, this query will update every record in your database with this information. So you have to really specify that I only want the record that matches the condition. So line number 5 is the condition. I'm saying I want where the first name is like Penelope and the last name is Guinness. So when you're using the AND operator, that means all the values must match. So for example, if the last name is Guinness and the first name is not Penelope, this query will not execute. When you're using the AND operator, that means all the conditions in the where clause must evaluate to true. So you can see here the first name is Penelope and the last name is Guinness. So this query is going to execute. So I'm going to execute this query. So as you can see here, it says 1 row affected. If I run this query here that I have highlighted to query all the records from the actor table, we can see that on line number 1, we now have Penelope Cruz. So the last name has been changed from Guinness to Cruz. The second task for exercise 13 is to update the language Mandarin to Mandarin Chinese. You can see in the table we've got it specified as Mandarin. We want to update that to Mandarin Chinese. This is the query for the second task for exercise 13. So we are updating the language table as specified on line number 1, and then on line number 2 we have the set keyword. It is in the set that you specify the field that wants to be changed, and we are setting the new value. You use the equals to set the new value. So we're setting the new value to Mandarin Chinese. Line number 4 is the where clause. The where clause is so important when you're updating records, because if you don't use the where clause to specify the record you want to update, it will update all the records in the database. You can imagine if you have over 1 million records and you omit the where clause, it will update all the records with this information. So you really have to be careful when you're updating records. In the where clause, we're specifying the filter, which will make sure that we only update the specified record in the filter. So line number 5, the filter here is the language underscore ID column. We can tell from the result here that the language underscore ID for Mandarin is 4. So that's why I've specified it here. So it will only update this record. So let me run this query. As you can see, it says 1 row affected. So let's query the table and see if that has updated. So I'm going to run this query here that I have highlighted. And if we take a look, we can see that this language has been updated in the database. It's now showing as Mandarin Chinese. Let's take a look at the solution to exercise 14. The task for exercise 14 is to remove the language Mandarin from the database. Before you delete any record from the database table, it's always a good idea to query the database. Before you remove a record from the database table, it's always a good idea to query the table first. So you take a look at the current state of the data. So I'm going to run this query here. So this table currently has 9 records. So we want to remove record number 9, which is Mandarin. because we also have a Mandarin Chinese, so we don't need this Mandarin, so we're going to remove this Mandarin from the table. This is the query I'm going to use to delete the record from the database table. To delete a record from the table, you use the delete statement, which I have specified on line number 1. So I'm deleting from the language table. On line number 2, I have the where clause. The where clause is very important when you're deleting records. If you do not specify the where clause, it deletes all the records in your database table. So you really have to be careful. So I specified in the where clause that I only want to delete the record that matches the language ID of 9. So I'm going to execute this query. As you can see here, it says 1 row affected. So that record should have been removed. So I'm going to quickly query the table. So I select this query here and run it. And if we take a look at the table, you can see that record number 9, which is Mandarin, is no longer in the table because I've deleted that record. Let's take a look at the solution to exercise 15. The task for exercise 15 is to list all the names of the actors that starred in the film Affair Prejudice. So we want the actor's ID, the actor's first name, and the actor's last name. The data I want is spread across 3 separate tables, so I'll need to find a way to join the data. But before I construct the query, I want to see the structure of each of these tables. So the first table I'm checking the structure for is the actor table. So this is the structure. So we have an actor ID, the first name, the last name. So I'm going to get the actor ID, the first name and last name from this table. Let's take a look at the structure of the film table. So this is the structure of the film table. So the film table, we have a film underscore ID, the film title, and other fields. But the one we're interested in is the film title. Let's take a look at the structure of this table called film underscore actor. And this table has the actor underscore ID. It has the film underscore ID. If we take a look at the film underscore actor table, we can see it has a film underscore ID. And if we look in this table called film, we also have a film underscore ID. So both tables are related using the film underscore ID. We also have a relationship between the actor table and the film underscore actor table. So the actor table, we have actor underscore ID, and in the film underscore actor, we have actor underscore ID. So that is where they are related. The next thing I want to do is to query the data in these tables. So I'm going to query the film table first and see the data we have in there. This is the data from the film table, and the film we are interested in is this film called Affair Prejudice. This film has a film underscore ID of 4, so we're going to be using that in querying the data. Next, I want to query this table called film underscore actor, so we can take a look at the data. So this table basically shows us the film underscore ID and also the actor underscore ID. So this table here, I know that the film we want has an ID of 4. I'm going to use this query here to query this table so I can see the data contained in that table. So I'm going to run the query. The result of the query has given me some information here. So I now have the actor IDs who starred in the film underscore ID 4. So I know that the film with an ID of 4 is called Affair Prejudice, which is the film I'm trying to find the data for. So I now know the data I need. I now need to build the query. This is the query I'm going to use to get the required data from the database table. I'm going to run through the query with you. On line number 1, we have the select keyword. On line number 2 is where I specify the columns or the fields in the table that are going to be displayed in the result of the query. So on line number 2, I've got ac.actor_id, ac.first_name, ac.last_name, and fl.title. The AC on line number 2 and the FL on line number 2 are referred to as aliases. Sometimes when you are writing queries, you can make the query shorter by using alias names for your table columns or the tables themselves. The alias names for the tables are defined in the from field. So you can see on line number 3, I've got the from, and then on line number 4, where I specify the name of the table, which is actor, after the name of the table, I've got as. You create an alias name for a table or a column using the as keyword. So on line number 4, after the name of the table called actor, I've used the as keyword to specify an alias name that the table will be referred to. So I've called this AC. You may find out that if you're in a big organization, the table might have a very long name. So when you're building your query, you may not want to use that long name all the time. You may just want to use an alias name to refer to that table. This makes your query shorter. On line number 5, I'm using an inner join. An inner join basically is used to select records that have matching values in both tables. So the tables that are participating in this join is the actor table on line number 4, and then on line number 5 we have the film_actor table. So on line number 6, again I'm using the as keyword to specify an alias name for this film_actor table, which is called FLA. On line number 6, we have the using clause. The using clause is used to match only one column when more than one column matches. So it will only match the one if you have several that matches. And the matching column here is actor_ID. So what that basically means, we have the actor_ID column present in the film_actor table and in the actor table. On line number 7, we have another inner join. So again, an inner join selects records that have matching values in both tables. On line number 8, we have the film table. Again, I'm using an alias here. So I've got the as, and I've given the alias FL to the film table, which are also used on line number 2 here in the title. On line number 8, I've also got the using clause, which is used to match only one column when more than one column matches. So I have the film_ID. This is because the film_ID column is present in the film table and also in the film_actor table. So they are related. On line number 9, we have the where clause. The where clause is where you apply a filter so that the data that is returned by the query matches what you've specified in the filter. So the filter is, I am looking for a film that is called affair prejudice. So FL here, remember FL represents this film table. It's just a temporary short name. When I execute the query, it will only return the records that matches this film called affair prejudice. So this is the query. As you can see, these are all the actors' ID, the first name and the last name in the film Affair Prejudice.